Hello students, we'll be talking in this module about the aerial photogrammetry, which is the fourth module of advanced surveying subject. So in this module we'll be talking more about the aerial photogrammetry, what are the application part of this, how we use this aerial photogrammetry in the present with respect to the present status, what are the different uses of them, as well as the in depth what are the applications or other how to identify or what to do. These all aspects will be studying in the aerial photogrammetry model. For example, this is an old technology, rather it started from the World War II or even prior to that. But over a time period when the satellite data came into the existence, this has uh, lose its importance as it was a costlier affair to take the aerial photograph. But in a recent day, since the drones have been developed, this has taken up again the boom in this field, and this is rather right now the more it has more application than the satellite data, as this will give the localized study with a very high resolution photograph. So in a simple way, you can say that now we have an image where this image is captured with a drone, and you can see that what all is present within this society. I'll say, okay, this is the society, we have got so many buildings. Among that, what are the facilities that we provided? If I want to see all these facilities, I have to enter into this and then I have to check. But here I can use this aerial photograph to check what all is present. I know that there is a swimming pool, there is a court, playing court, there is a badminton court, then there is the volleyball, football, basketball courts. So these are all applications. I can see it with the help of remote sensing. Not only that, I can, with a single photograph, I can check how many story buildings are this, and same way here based upon the number of windows. Okay, and even to the highest extent, I can calculate what is the area of these buildings. Okay, so all things can be possible with the help of remote sensing, or I can say with the aerial photogrammetry. Not only this, there are much and much applications. I am just talking about a photograph of a building. With this, I am able to retrieve all this data. But over a time period, if you go into the depth of this, you will understand that there are more and more applications of this with respect to the aerial photograph. Or as I said, this is right now emerging and trending. Not only this, even you can find out the height of these buildings with the help of concept called as the relief displacement. It is a concept called as relief displacement. With that, we can identify what is the height of the buildings as well. Okay, so one by one we'll be talking about these aspects in the next few classes. Just to make you more interesting, I would like to show you some of the videos which has been captured with the help of drone and how they are being used in the remote sensing or the aerial photogrammetry. Okay, this is the video of our own institute where which has been captured with the help of drone. Now imagine if I want to see my own institute in this fashion, it's not hardly possible. I can, by standing in our parking, we can see, okay, there is a whole institute, but it is not possible to capture the entire institute in a single look. And that facility has been provided by the drone surveying or the aerial surveying. In the last module or the last class, probably we'll discuss more about how we have used the satellite images or the drone images for understanding or for carrying out the different surveys or the image retrievation, how we created a 3D model of our own institute. We'll be discussing in the last class, probably in the last class of this module. Okay, so this is the Polytechnic Institute. With this image or this video, I can probably by taking the images, I can calculate what is the area of the ground, what are the areas of each building, and then how many columns are there, how many which are the areas where even when to the highest extent I can identify where there are the cracks in a building, uh, because it's not practically possible to go and retrieve each and every single cracks. So that cracks also can be identified with the help of this aerial photogrammetry. Okay, these are the application parts of the aerial photogrammetry. Okay, so with respect to I'm sticking to the civil engineering applications of this aerial photogrammetry. Yeah, I can identify where there are cracks, where there are dumps. There are many concepts can be understood or can be studied. This is our own civil engineering department, which has been captured with the help of the aerial photograph. So let us move to understand how this aerial photogrammetry started. So there was a photographer who was very enthusiastic in capturing the various data. So what he tried is he tried to move on the he tried to capture the photograph of the area with the help of the uh, balloon. Okay, and he understood that by looking the photograph from the top, it will be very good. We'll get the more picturized thing, or we'll understand many things out of this. So he said, okay, let's use this technology for capturing the areas. Then furthermore, when this concept evolved, they said instead of balloon we can take kites. With the help of kite, you can see this is a camera which has been attached to the kites, and the kites will be flying, and they'll be taking a more picture because they can go to the higher heights than this air balloons. Then they wanted something which is remotely used, especially during the World War. They wanted to use this technology in understanding what all is going on in the enemy area. So what they did is they attached the camera to the pigeons, and they sent these pigeons on to the enemy areas. And with the help of this camera, they will be able to capture what all instruments, where there are bunkers, and all this information they can retrieve from the with the help of camera with the photographic proof. And these photographs are geo-referenced. The meaning of geo-reference is that they have the lat long lat and longitude latitude and longitude on this area. So when they have latitude and longitude, it is very easy to determine where there is a location of this. All information can be retrieved, and they make use of this technology to identify the enemy hidden places and all this information with the help of pigeons. Over, you can see this is the bird which has attached with the camera. Okay, so this camera, how it will help is, now you can say that this is a camera which has been attached. Now it will capture whatever is there on this earth. Whatever is there in this earth, it will get captured, and this information can be retrieved. So this is how they have make use of the pigeons. Later on, when the Wright brothers identified the invented the helicopters, they said let us attach a camera to the helicopter, because the movement of pigeon cannot be in a straight line, always cannot be in a straight line. It will be in a bit zigzag fashion, or it may take a random turn, sudden turns and all this. So to avoid this, they attach a camera to the helicopters, and with once they attach the camera to the helicopters, they were able to capture the images, sequential images of the area in a patch manner. Once later on, when they say, if I say this is 1, this is 2, this is 3, and this is 4, then they can attach them and they can make a single image out of it, and this will help in order to get the more and more information. Not only this, if I take this picture, I'll take a single picture, then I'll cover 60% or 30% of first picture area in this. So this is overlapped area. Same way in the next picture I will do. So this is again the overlapped area. This third picture I will take. This is called overlapped area. Once I overlap such areas, by overlapping, I'll get more information, and I can see that images are can be converted to the 3D. So with the present drone scenario, we are doing the same thing. That's called as overlapping concept. overlapping concept to get a proper information or to get the 3D out of these pictures. And this is the reason why we'll get the along with x y component, that is lat and long, we'll get z component also, that is the height of the building. And this height of the buildings or the elevation point will also help in order to create a 3D, and this 3D will help in order to understand the detailing of the studies will be more with respect to the 3D images. So now in the present study, this is taking a boom out of this areas. And now let us see another video which is again shooted with a drone. So here we can see that this you can see the clarity of this. You can imagine what are the area, how much is the area, and all this concept can be understood. But my ultimate aim is not to show about the area. This image will be probably with respect to the so-called fun. You can use this. You can see the beauty of the ocean here. You can see the beauty of the ocean, and you can see to the what angle, how angles we can capture the videos of the out of the drones. Okay, and you can see the tilt, you can see the movement is happening with the help of camera. Okay, you can check this movement has something to do with, there is a some very good relation or the very beautiful relation with this tilt or the movement of the camera with respect to the aerial photograph. Based upon this, the images are developed, images are classified, and not only that, the information retrieved out of this varies with what angle the camera has been seated, with the varies with what angle the camera has been fitted. Okay, so these were our pretty last year students who got passed out. There was one student called as Nabil, and he has shooted this video on one of the beach in probably in Goa. They were able to capture this, and he has beautifully captured this image. You can also enjoy the beauty. As I discussed in the previous photographs or the previous slides, that there are different types of photographs. Okay, so these different types of photographs will help us in order to understand the coverage of the area, and then there are based upon that there are many uh, application parts. So these different applications we'll see one by one. First, let us see the different types of photographs. Different types of photographs. So in this, the first one is vertical photograph. First one is vertical photograph. Imagine that this is the aircraft which is moving in this direction. Okay, the line along which the aircraft moves, is called as the flight line. Is called as, I'll say this is flight line. It's called as a flight line. The line along which the aircraft moves is called as the flight line. Now I have fixed up the camera at this location, and this is my perspective projection, or the center of the photograph. Now I'll be imagine this is my photographic plate on which the image will get captured. Imagine there is a house at the bottom of this area where it has been captured. Then there is a human being. I'll consider these two things. So with respect to the vertical photograph, I'll be able to see only this part. I'll be able to see only this part. While in case of human, I'll be able to see only the head. I'll be able to see only the hair part. But I'll not be able to identify the person. I'll not be able to identify the face of the person. I'll not be able to see, rather, because this is completely a perspective vertical projection. It's completely perspective vertical projection. Is as good as you are standing here. You are standing here. Okay, this is your position, and you are looking exactly at the bottom. You are exactly at the bottom. This is called as vertical photographs. Then the next comes called as tilted photographs. Called as tilted photographs. Okay, so these tilted photographs are, imagine this is the flight in which it is moving. So this is my flight. Okay, even though it look like a fish, but considered it's a flight. Okay, so this is my perspective projection, but my photographic plate or the axis is not exactly vertical. Here it has tilted a bit. This is tilted a bit. This tilt will be less than 3 degrees. This tilt will be less than 3 degrees. In this, what will happen? This, see, imagine this will be the tilt. For example, I'll explain what exactly means with the tilt. Is this is my imaginary horizontal position. With to that there is some angle. There is some angle which will get recorded. Get recorded. This is called as tilt. This is called as tilt. Same thing is happening here, but this tilt is not intentional. This tilt is not intentional. This is happened because of the human error, maybe because of the moving movement of the flight, because of the wind directions, and all these parameters are responsible for it. But what will happen here is, now if this is my house, this is my house, and here there is a human being who is standing, I'll be able to see this part. I'll be able to see if there is a window here. I'll be able to see that window. Okay, I'll be able to see the human face. I'll be able to see the human face also, because of the small tilt. But what will happen here? Here the scale at this corner will be same. Scale at this corner, or throughout the photograph will be same, but here the scale will change here. The scale will change here because of the this tilt. The scale will change here. Okay, so this is called as tilted, but be clear, the tilt should be less than 3 degrees, and this tilt is not intentional. This tilt is, we'll say, unintentional tilt. This is unintentional tilt. While the third type of photograph is called as the oblique photograph. Called as oblique photograph, where imagine this is my aircraft again. This is the flight line, the windows in which you are sitting, and this point is my perspective projection, downward direction. But what I'll be doing is, here I'll be giving some tilt. I'll be giving some tilt intentionally. Here my tilt is very intentional. I am saying it, it is intentional tilt. With some purpose I had tilted. So what will happen here? This is my house. This is the human being who was standing. Now I am able to see the entire human being. Now I am able to see entire building or entire house. With this photograph here, I'll not be able to find out the height of the human being, but here I can find out the height of the human being because of the tilt is bit tilted. Tilt is bit higher side. This tilt can be close to 15 degrees or less than that. It can be close to 15 degrees or less than that. So this oblique tilt, or this is called as oblique photograph, has capacity to the rather this has a more application part. But what will happen again here? Here this side of this photograph will be has a different scale. This side of the photograph have a different scale because of the tilt. Because of the tilt. So when the similar thing happens, uh, that this is a perspective projection. We'll talk about this part, perspective projection, projection principal point, and this part in a next few classes. But let us understand one more point here, that here again when the oblique photograph comes, there are two types. One is high oblique, one is high oblique, another is low oblique. Okay, one is high oblique and another is low oblique. Let us see what exactly means by the high oblique and low oblique photographs. Okay, so now first let us talk about the high oblique photograph. Let's talk about the high oblique photograph. Now imagine this is my aeroplane. Every time it is changing in shape because of my poor drawing. Okay, and now my perspective projection is this, while other corner of the photograph is this. Now what will happen with this? My angle is bit on the higher side. My angle is on the bit higher side. Now because of this bit higher side angle, what is happening is I am able to see my entire building. I am able to see the entire person. Apart from that, I am able to see the horizon also. I am able to see the horizon also. Okay, this imagine this is the line is called as horizon. What do you mean by horizon? Horizon is a place where the land and the ocean seems to meet at one point. Land and the, we can say, land. Okay, land and the sky appears to meet at one location, that is called as horizon. So if I am able to see this horizon, it is understood that these are called as high oblique photograph. Okay, and in case I am not able to see this horizon, I am not able to see this horizon, then it is called as low oblique photograph. It is called as low oblique photographs. Here horizon will not be appeared, but there is a tilt. The horizon is not appearing, but there is a tilt in the photograph. Okay, so this tilt will help us to understand, or I will say, again, scale point remains here, scale is different here, scale is different here. Sometimes here in this location you will not be able to see anything clearly. The objects which are present at this location are very clear, the objects at this location are not at all clear because they are far from your the aeroplane. They are far from the aeroplane. So here the object which are available here, they are not very clear. The scale of this is very different. Scale of this is very different. For example, now if I take this as my image, which has high angle. Here you can see there is a, you can imagine there are only buildings. There are only buildings here, and my aeroplane is over here. Now it is moving in this direction. Okay, the buildings here are very clear, but as we go far, the building's size will differ. Building size will differ. At the corner, the last of the photograph, you'll be able to see only the dots. That's because it is tilted. That is because it is tilted, and because of which the scale will be not same throughout the image. Okay, that's the disadvantage of high oblique photograph. While in case of low oblique, what will happen, the same remains, the even the scale is not equal, but much of the distortions may not happen. Much of the distortions may not happen. Thus we prefer to go for low oblique photographs. We go for the low oblique photographs because, as I said, this has a bit of 3D perspective. It has a 3D perspective because this will can give you the along with x, y, that is lat, long, and the z, that is elevations also. Elevations, and if you get the elevation, then you can easily identify the heights. You can identify the heights and you can create the very 3D images, very 3D images. Okay, so this is the difference between high and low angle. In continuation to this, we'll see another part. We'll see another part, that is how to how this survey will be done. Just I will give a brief here. Imagine this is my area which I want to capture. This is the area which I want to capture, but here the ultimate aim is to create 3D out of it. 3D out of it. So it is not that a single image of this area is sufficient. Here what we do, my aeroplane will be, or rather now I'll say a drone will be moving from this corner. It is shifting back. Again it is moving in this direction. Continuously moves in this direction and covers as much as possible photographs. It covers as much as the possible photographs. Then not only this, to get the accuracy, the flight will be moving in this direction. So we cover the each and every component of the building, then only with something called as overlapping. We'll be doing this with something called as overlapping. Imagine this is already explained, but let me repeat it once again. Here this overlapping also taking place. There will be a continuous successive image will be captured by keeping some portion as the overlap portion. So this portion is the overlap portion. This portion is the overlap portion. Not only this, not only this, this is called as the overlap. There is something called as side lap also. Now when the flight is moving in this direction, when it turns back, here the capturing will take place by covering almost 30% of this area. Almost 30% of this area. So every photograph, this part will be again repeated. This part is also again repeated. So this help us in order to get the side lap of the area, and this is how a 3D image will be get created. These 3D images are again further used for many and many purposes, which we'll see in the successive classes, where we'll talk more about this. You can see this, there's a tilt is happening. The camera is getting tilted. It is adjusting itself. It is adjusting itself, or rather we have a capacity to do that with the help of pointers, with the help of control. We can do the similar thing. Now this is exactly vertical. This is exactly vertical, where we are able to capture from the top. We are able to see the capture from the top. Such photographs are called as vertical photographs. Such photographs are called as vertical photograph. You can see exactly vertical below. Now it's shifted. Now able to see the horizon here. We are able to see the horizon. This is the horizon. This is the horizon where land and ocean seems to be meet at one location. This is called as horizon, and that horizon is such photographs are called as inclined photographs. Now again this has become the vertical. Here there is a center now. Here there is a center now. Center of the video camera. This is vertical. When it tilted, either it goes to oblique, a little bit tilt also can be called as oblique, or where you see the horizon is called as the so-called the inclined photographs. Okay, so this is with respect to the images. With respect to the images, kindly like our videos, like, subscribe, and share videos for more such videos. uh, this fourth and fifth model is already uploaded. You can check on our YouTube channel for those modules videos.